Imagine you are standing at the edge of everything, not the edge of a country, not the edge of a continent, not even the edge of the atmosphere. You are standing at the exact point where the sun's power ends, where its light, its heat, its magnetic grip on reality finally gives up. Beyond this line, there is no solar wind, no protection, no warmth, nothing that was ever designed to keep anything alive. And somewhere out there, moving away from this line at 38,000 miles per hour, is the farthest object humanity has ever sent into the cosmos. It has been traveling for 47 years. It cannot stop. And what it is heading into? We don't fully understand yet. This is not a story about exploration. This is a story about what happens when you throw something into a darkness so vast, so old and so indifferent that even light takes years to cross it. This is the story of Voyager 1. And the further you follow it, the more terrifying it becomes. When it launched in 1977, the world watched a rocket punch through a pale blue sky and disappear. It felt like triumph. It felt like humanity reaching out with open hands. And for a while, that's exactly what it was. Voyager sailed through the solar system like a dream. It passed Jupiter and saw a moon erupting with volcanoes we had never imagined. It swept past Saturn and sent back images of rings so perfect, so geometrically beautiful, that scientists wept looking at them. For a moment, the universe felt like a gift, ordered, majestic, ours to discover. But here's the problem. The further Voyager traveled, the more the universe stopped performing for us. The beauty began to peel back, and what was underneath it was not wonder, it was warning. In 2012, after 35 years of flight, Voyager 1 crossed a threshold. Scientists called it the heliopause, the invisible bubble where the sun's solar wind finally collapses under the pressure of interstellar space. For billions of years, that bubble has been the only shield between everything we know and the full violence of the galaxy. Our atmosphere protects us from radiation. The magnetosphere protects us from charged particles. But the heliosphere, this enormous invisible envelope of solar energy surrounding the entire solar system, that is the last line, the outermost wall. And Voyager punched through it. And what it found on the other side was not what anyone expected. The plasma was denser. The magnetic field was stronger. The cosmic ray bombardment, high-energy particles fired across the galaxy by ancient supernova explosions, was dramatically higher than every model had predicted. The universe outside our solar system was not quiet. It was not thin and cold and peaceful. It was a hostile medium, a place where the galaxy itself fires radiation at you continuously, where the physics is different, where nothing we built our understanding of space on actually applies. Voyager had crossed into a region that no instrument had ever sampled from the inside. And what it was measuring was rewriting everything. But it gets worse, because while Voyager was sending back this data, this extraordinary, world-altering data from the edge of known space, it was dying. The power source aboard it, a small generator fueled by the radioactive decay of plutonium, had been fading since the moment of launch. Every year, a little less electricity. Every year, another heater switched off to conserve power. Another instrument silenced to keep the transmitter alive. By now, the craft is running on the wattage of a refrigerator light bulb. A 22-watt signal fired into the void, taking over 22 hours just to reach Earth at the speed of light. 22 hours, and another 22 hours before any response could arrive back. 44 hours round trip to manage a machine you cannot see, cannot reach, and cannot repair. And then in 2023, it started speaking in tongues. The flight data system, one of Voyager's 3 onboard computers, began broadcasting nothing but corrupted noise, a repeating pattern of meaningless code, billions of kilometers from Earth, in the middle of interstellar space, pouring out of a machine that was last physically touched in 1977. For 5 months, there was nothing usable, nothing interpretable, just static from the darkness. Engineers at NASA's Jet Propulsion Laboratory sent commands and waited 2 days for each response, diagnosing a hardware fault they could not see on a spacecraft they could not touch, with technology that predated the internet by a decade. They were performing surgery on a patient 44 light hours away using only the sounds it made. And they fixed it. They actually fixed it routing around the damaged memory chip through commands so precise and careful that one wrong instruction would have ended the mission permanently. But the fact that it broke, the fact that cosmic rays had been hammering the memory chips for 4 decades until one finally failed, that tells you something. Voyager is being destroyed out there, particle by particle. The galaxy is eating it, and this is where things change. Because ahead of Voyager, in the direction it is traveling, there is something our models predict but our instruments have never confirmed. The interstellar medium is not uniform. It is not just empty space with a steady cosmic ray flux. There are clouds. Real, physical clouds of gas and dust, warmer or denser than the surrounding medium. Regions where the chemistry changes abruptly, where the magnetic field environment shifts without warning. Our solar system is currently moving through one of these clouds, a diffuse bubble of warm gas roughly 30 light-years across, called the local interstellar cloud. And the models suggest we may be approaching its boundary. What exists beyond that boundary, the next cloud, the next density change, the next shift in the galactic environment? We are inferring from mathematics and inference alone. We have never been there. No instrument has ever been there, except that one, except Voyager. And it is heading there whether we understand it or not. But that's not even the worst part. The worst part is what lies further ahead. Not years further, not decades, centuries. Approximately 300 years from now, Voyager 1 will reach the inner edge of the Oort Cloud, a spherical shell of icy objects surrounding the sun in all directions, extending nearly a quarter of the way to the nearest star. A structure so enormous that it has never been directly observed by any telescope. Its existence is inferred only from the trajectories of long-period comets that occasionally fall inward from its depths on orbits measured in millions of years. No probe has ever imaged it. No instrument has ever measured it directly. Its contents, its density, its structure, these exist only in our models. And Voyager will arrive there in 300 years, carrying humanity's most advanced interstellar instruments, the only direct physical presence we have ever sent into that space. And it will cross into the Oort Cloud in complete silence. Because by then the power will be gone, the transmitter will be dark, Voyager will be a dead machine passing through an unknown structure in a region of the solar system we have never seen, and we will receive not a single bit of data from it. The greatest scientific encounter of the next 3 centuries will happen in absolute silence. There is a gold record aboard Voyager 1. It carries greetings in 55 languages, music, the sound of rain, a mother's voice speaking to a newborn child. Carl Sagan, the man who designed it, called it a message in a bottle thrown into the cosmic ocean. He meant it hopefully. But hold that image against the actual physics of where Voyager is going, and the hope begins to feel like something else. The nearest star system is 70,000 years away at Voyager's speed, and Voyager is not even heading toward it. The spacecraft will wander through the interstellar medium for hundreds of thousands of years before it comes anywhere near another star. In that time, every language on that record will have changed beyond recognition. Every civilization that contributed to it will have transformed into something unrecognizable or ceased to exist entirely. The spacecraft carrying it will be cold and inert and dark, drifting through a medium it cannot measure, carrying voices from a species that may no longer be here to remember it sent them. Right now, there are people at a facility in Pasadena whose job is to listen. Every day, using antennas the size of football fields to catch a signal weaker than the light of a birthday candle seen from across a city. They have been doing this since 1977, and within the next decade, the power will drop below the threshold required to keep the transmitter alive. The signal will stop, the voice from the edge of the solar system will go quiet, and Voyager will keep moving. It will still be out there, still covering distance, still carrying that record. In 10 years, in 100 years, in 1,000,000 years, still moving deeper into the interstellar medium, into the Oort Cloud, through the space between stars. The universe does not care that we built it. It does not care that we launched it with hope. It does not care that we listened for 47 years. The cosmos has been here for 13 billion years, and it will be here for trillions more. And in that span of time, our entire civilization, every war, every discovery, every moment of love or fear or wonder, is not even a flicker. Voyager 1 is the furthest we have ever reached, the absolute maximum extent of every human effort ever aimed at the sky, and it is a 47-year-old machine from 1977, running on the power of a dying lamp, speaking in a whisper that takes 22 hours to arrive, heading into a darkness it will cross forever. We sent it out there because we could not help it, because we are the kind of creature that looks at an infinite and indifferent universe and decides quietly to throw something into it anyway. Not because we will get an answer, but because something in us cannot stand the silence.